It's a delight to be here, and it's good to see at least some people trickle in. But this is intended to be a very collaborative kind of talk, so please feel free to ask questions, interrupt me, and we can take it as it is. And whenever they pull us off, we'll go off. So the advertised title of this talk is The Evolving Internet of Things, and I kind of put this talk together. It's a dynamic talk that will evolve as we speak. Before I begin, I'd like to acknowledge the people of EFY 2012 in inviting me here. So I just found out 2 days ago that I'm going to be talking here. I'd also like to thank all of you for actually showing up here when you could be somewhere else. And I'd like to thank and acknowledge some of my colleagues and collaborators at Stanford, Berkeley, and industry and government. So the agenda, again, this is very flexible for what I'm planning to talk about today, is I'll briefly set the context, presume that you don't know anything, and tell you what the evolving Internet of Things is. I'll then share some perspectives that relate to technology, research, business, and society. Okay. And I'll draw from examples and applications that I've worked with, some in the smart grid arena. I'll also talk about things like streaming data and its implications, its relation to wireless devices and mobility, intersection with some of the things like security, etc. So we'll jump around a little bit. It's a big area, but I just wanted to touch on a few things. And then we'll try and wrap up by summarizing some of the key takeaways and a call to action. So I'm told that the audience here is 75% or 70% technologists, 5% executives, and 20% students. Is this so? How many students are in the audience? Oh, wow. Okay, that's very good. So this is like 70% students. And how about executives? We have, okay, so we have a good, I guess that almost might be 5 to 10%, depending on the crowd here. Okay, so that's good, because I'll come back to that, and I'll talk about it in the call to action, right? So the context and premise of all of this is that we are transitioning, or in fact have transitioned, depending on how you view this, to a new era of computing, where you pretty much have everything computing to some level and everything networked at some level. So we have billions of computing devices embedded within objects, many of them sort of all around us, acquiring and acting on a multitude of data, and generally serving to improve the quality of our lives by making us and enterprises more productive. Okay, that's what this Internet of Things is supposed to be all about. And this transition will essentially spawn new technologies, and I'm hoping some of them will be contributed by people in the audience. It'll also change some of the paradigms of the way we do things and the way businesses operate, and have significant societal impact in the long term. Okay, so just to give you a different perspective, and I'll sort of run through some examples. I've got to figure out how this thing, oops, what did I just do here? Okay, I'll just point here. So this is talking about, what is the Internet of Things? So it's basically everything, although depending on where you've heard this term, you might think of it as, from a biased point of view, as something. So this is talking about things that we normally, think of as the Internet of Things. So at the core is the cloud or the infrastructure where big iron runs, communications, stuff like that. In the middle here is what you can call mobile access devices of different types, phones, pads, laptops, and things of that type. And the outer circle, which you can't see very well, or at least I can't because of the coloring, is a sensory swarm of things that's embedded in the ambient environment. Okay? So those are sensors and actuators that can be in pretty much anything around us. But I've also thrown into in this Internet of Things, I've pulled out a few things that are not normally associated with the little things that are around. So that includes things like cloud, where another giant infrastructure is, and revolution is taking place. And then there's the enterprise, which is also being affected by some or all of these things. And in addition to these sensors, actuators, and wireless, actually things, we're also things at some level. And then there's a lot of data that's feeding in from things like websites and blogs and tweets and social behavior all around us. So that's this entire Internet of Things. And the numbers are huge. These are actually old numbers, and I won't belabor them. But the point is, at the top, when we're dealing with things that touch people, obviously you're approximating the number of those devices on the order of 3 to 4 billion, because the number of people on the planet is 6 to 7 billion, growing but at a slow rate. Okay. And then we go on to devices, and if you add all the 1,000 radios per person that's projected to occur at around 2025, plus minus 5, 10 years, you will have trillions of devices, all networks. But some of them are going to be inside of us, and this is just a very brief sample of those, things like deep brain neurostimulators, cochlear implants in our ears, for those of us who can't hear too well, gastric stimulators in our stomach, cardiac defibrillators, things like insulin pumps for a lot of the people who are diabetics. And then there's stuff that's outside of us, right? So this is some snippets of the Curiosity rover. The backdrop is the NASA control room. That's the initial artist impression. Those are some of the components in there, and this is a picture that Curiosity beamed up about 10 hours ago. So it's actually, this has got nothing to do with the talk, but it's kind of interesting. It's laying out some footprints in Morse code to actually measure the distance it's traveled. And of course, this is in Mars. So this is also a thing, and we're interacting with it, right? And then I thought I'd share with you some things that you might not have seen or heard much about. There are also things in stuff that's around us, plants. But this is an example of an insect. This is actually a beetle. It comes from a South African origin. And it's, as shown here, it's about the size of this palm. Okay? It's actually an interesting beetle, and it's not as scary as it looks on this surface. You can hold it in your palm. And the initial experiments here were to try and control the flight of this beetle via some circuits that were implanted in there. So you can sort of go in, implant the RF circuits, and then you can actually control the flight of the beetle. I don't, unfortunately, have the movie which shows that, but you can trust me that, in fact, if you can, by giving some neuromuscular stimulation, you can actually control the flight of the beetle, to tell it to stop, turn left, turn right. And it's fairly fascinating. But the other fascinating thing, just to push this for a minute or so, this is how the beetle actually evolves. It goes from the larva through the beetle stage and eventually sort of becomes a thing that can fly. And up here is the timescale. The point of this is to see if we can actually fuse and interface things like RF circuits into the sensory organs of these little devices. It might be a frightening thing or a scary thing or a odd thing to think about. The question is, can you do this? And the beginnings of this actually suggest that you can. So the goal here is to have these sensory organs implanted with flexible perforated substrates early in the pupation stage of the evolution, and you have to be careful. If you do it too early, it won't stick around. If you do it too late, the thing will die. Essentially, it won't do it. And it turns out that you can, in fact, do it. And here's an example of something that was implanted in the eye and neural cortex of that thing. They don't have much of a neural cortex. And then it becomes an integral part of this beetle when it actually fully matures. And you can actually sense and control things. This was the RF antenna strip that's poking out of that beetle. So it's stuff that you can actually do, and then again you can control the flight of the beetle and measure what's happening inside of the beetle, and that's the reason for doing this kind of an experiment. So basically the applications of all of these things are many. They're well known. They're in the house and automobiles and the smart grid in our body and so on. And you can actually, people have done a lot of taxonomy and categorization. There's an eye chart that I won't read, but the whole thrust of this is there are applications in buildings, industrial, healthcare, transportation, retail, energy, security, networking, what have you, of what this can entail. Okay. But yet, the reality has been that the adoption of all of this, so the technology and the notions are not new, but the adoption has been slow. And one can try and see why this has been the case or why not. And what this is trying to tell you is that this is just a random thing. About a couple of years ago, in 2010, the entire sensor market was about 10.3 billion. The projected wireless sensor market was 5.3 billion, and the actual wireless sensor market was about $500 million. So it's the take-up in terms of transfer to reality and commerce has been much slower than might have been projected like 10 years ago, right? It's not zero, but it's not there yet. And you could argue or sort of ponder on why this might be the case. Cost savings might not yet be disruptive. There are reliability problems. There's the issue of not wanting to replace batteries, and many of these operate in places that you don't really want to get, or they're not easy to get to, and so on. And the economies of scale have yet to develop. Okay. So that sort of tells you about what we're talking about here in terms of things. It's almost everything, right? So that's too big a set. But the value as we progress actually lies in the intersection of these things that comprise this Internet of Things. So basically, the first thing that you get to is the devices, and then the devices get connected. You merge that with the newer evolving technologies such as cloud and the enterprise mobility and the machine-to-machine communication. So that's what yields this Internet of Things. And the key thing to note is that what this does is it transforms a product company into a value-added services company. Okay? And that is really the business implication that is important to note and understand. Right? So because once you think of yourself, and this is a difficult transition to make mentally and from a corporate standpoint, you don't think of yourself as a product company, but as a value-added services company, then basically you learn that by putting these things out, you get a closed loop with the customers. This is a continuous loop. The customers might be machines. So you can instrument what's happening to the humans, to the machines, and by doing this, you can understand them better, service them better, and act appropriately. Okay. So that's, I think, the key takeaway from a business standpoint. Okay. So unlike the other talks, perhaps in this conference, this is not a nuts and bolts talk, so I apologize for that up front. Right? But maybe you can ask me questions, and I can see if I have any nuts and bolts answers. Otherwise, we can always adjourn early, and you can go and have a cup of tea. Right? So I'm going to switch gears a little bit and talk about a couple of other implications of what happens when we have all this stuff going on around us. And there are a couple of things that I will talk about. I'll talk about how this is actually manifesting in some applications like the smart grid. And some of you might not be aware of the smart grid, so I'll talk about that. But I guess the way this is sequenced, I've also had something about streaming data in here. Right? So one of the implications of all these things all over the place is that, including people and blogs and so on, is that we have a ton of data. And most of it is garbage, but we have to process it and do something intelligent with it. Right? And it also affects our day-to-day life in terms of security. So, and just going with the flow here, let me take a little poll. How many of you in the audience have heard of Jason Bourne? Oh, okay. Good, at least a non-zero fraction, but okay, let's see if this works. This is an introduction to a little bit of Jason Bourne. Let's see if this works. While this is buffering up, it's an interesting thing, but it tells you about the stuff that's all over the place. Right? Can you hear it?